Welcome to my channel. Here, you're free to explore and learn industry standards, tips and tricks, and various other exciting topics. If you find the content helpful, don't forget to like, share, and subscribe to stay updated with my latest videos. Your feedback is incredibly valuable to me, so please let me know how I can improve the quality of our content. Enjoy your journey, and happy learning.
Data analysis is about finding meaning in information. We collect data from different sources, then clean and organize it. This helps us discover patterns and trends. These insights can guide better decisions. Data analysis is like detective work. Imagine a detective at a crime scene. They gather clues and piece them together. Analysts do the same with data. They look for clues to solve problems. They use data to tell a story. This process is important in many fields. Businesses use it to understand customers. Scientists use it to test theories. Governments use it to make policies. Data analysis helps us understand the world better. The power of data analysis lies in its ability to reveal hidden truths. It's about turning raw information into actionable knowledge. With the right tools and skills, anyone can unlock the power of data. Data analysis is revolutionizing industries across the board. In healthcare, it helps improve patient care. Doctors can analyze medical records to diagnose diseases earlier. Hospitals can optimize their operations and allocate resources more effectively. In finance, data analysis plays a crucial role in managing risk. Financial analysts use data to make investment decisions. They track market trends, assess economic indicators, and build financial models to mitigate risks and maximize returns. Marketing relies heavily on data to understand consumer behavior. By analyzing customer data, marketers can target their campaigns more effectively. They can personalize messages, optimize ad spending, and measure the success of their marketing efforts. Even in sports, data analysis is changing the game. Teams use data to scout opponents, analyze player performance, and make strategic decisions during games. Data-driven insights can give teams a competitive edge. Several tools are essential for data analysis. Microsoft Excel is a widely used spreadsheet program. It is great for organizing, cleaning, and visualizing data. Excel is user-friendly, making it a good starting point for beginners. SQL, or Structured Query Language, is designed to manage data in databases. It allows analysts to extract specific information from large datasets. SQL is essential for working with relational databases, which are commonly used in businesses. Python is a versatile programming language with powerful data analysis libraries. Libraries like Pandas and NumPy provide tools for data manipulation, analysis, and visualization. Python's flexibility makes it popular among data scientists. R is another popular programming language for statistical computing and data visualization. It offers a wide range of packages for data analysis, statistical modeling, and creating compelling visualizations. R is favored by statisticians and researchers. Data analysis requires a blend of technical and soft skills. Proficiency in tools like Excel, SQL, Python, or R is essential. Understanding statistical concepts and data analysis techniques is crucial for extracting meaningful insights. Critical thinking is paramount in data analysis. Analysts must be able to identify patterns, draw conclusions, and evaluate the validity of their findings. Strong analytical skills help separate meaningful insights from noise. Communication skills are essential for conveying findings to both technical and non-technical audiences. Data analysts need to present their insights in a clear and concise manner using visualizations and storytelling techniques. Problem-solving skills are at the heart of data analysis. Analysts are often tasked with solving complex business problems using data. The ability to define problems, break them down, and find data-driven solutions is highly valuable. Data collection is the foundation of any data analysis project. It can be gathered from a variety of sources such as databases, APIs, surveys, and sensors, depending on the specific problem at hand. Once collected, the data needs to be cleaned and prepared for analysis. This crucial step involves handling missing values, correcting errors, and transforming data into a usable format to ensure the accuracy and reliability of the analysis. Indeed, Data cleaning is often the most time-consuming part of the process, requiring meticulous attention to detail and a thorough understanding of the data. However, clean data is essential for producing accurate and meaningful insights. Data analysts employ various techniques for data cleaning, including data validation, data transformation, and outlier detection, using a combination of tools and techniques to ensure data quality. Section 6. Data analysis techniques. Data analysis encompasses a wide range of techniques. Descriptive analysis summarizes the main characteristics of a dataset, providing a general overview of the data. Measures of central tendency, such as mean, median, and mode, are commonly used in descriptive analysis. Exploratory data analysis, or EDA, aims to uncover patterns, relationships, and anomalies in data. It involves visualizing data, calculating summary statistics, and performing hypothesis testing. EDA helps formulate hypotheses for further investigation. Inferential analysis goes beyond describing data to make predictions or generalizations about a larger population based on a sample. It involves statistical techniques like hypothesis testing, confidence intervals, and regression analysis. Predictive analysis uses historical data to predict future outcomes. Machine learning algorithms are often used in predictive analysis to build models that can forecast future trends, customer behavior, or stock prices. Section 7. Real-world applications of data analysis. Data analysis has countless real-world applications. In healthcare, it helps predict patient readmissions, optimize hospital operations, and accelerate drug discovery. By analyzing patient data, healthcare providers can identify high-risk patients and intervene early. In finance, data analysis powers algorithmic trading, risk management, and fraud detection. Financial institutions use data to make investment decisions, assess creditworthiness, and detect fraudulent transactions in real time. In marketing, data analysis drives targeted advertising, customer segmentation, and campaign optimization. By understanding customer preferences and behavior, marketers can deliver personalized experiences and increase conversion rates. Data analysis is also transforming the transportation industry. Ride-sharing companies optimize routes and pricing using real-time data. Logistics companies track shipments, optimize delivery routes, and improve supply chain efficiency. Section 8. The future of data analysis. The field of data analysis is constantly evolving. Artificial intelligence and machine learning are transforming the way we analyze data. AI-powered tools can automate data cleaning, identify patterns, and make predictions with increasing accuracy. Machine learning algorithms are being used to build predictive models in various industries. These models can forecast customer churn, predict equipment failures, and personalize recommendations. As AI and ML technologies advance, their impact on data analysis will only grow. The rise of big data presents both challenges and opportunities for data analysts. Big data refers to extremely large and complex datasets that traditional data processing methods struggle to handle. New technologies and techniques are being developed to manage and analyze big data. Data privacy and security are becoming increasingly important concerns. As we collect and analyze more data, it's crucial to ensure that data is handled responsibly and ethically. Data analysts need to be mindful of privacy regulations and best practices. Section 9. Career paths in data analysis. The demand for skilled data analysts is soaring across industries. Organizations are seeking professionals who can extract insights from data and drive data-driven decision-making. A career in data analysis offers promising job prospects and competitive salaries. Data analyst is a common entry-level position. Data analysts are responsible for collecting, cleaning, analyzing, and visualizing data. They work closely with business stakeholders to understand their needs and provide data-driven insights. Data scientist is a more advanced role that involves developing and applying machine learning models. Data scientists typically have a strong background in statistics, programming, and domain expertise. They are sought after by companies looking to leverage AI and ML. Data engineer focuses on building and maintaining the infrastructure for data collection, storage, and processing. They ensure data quality, reliability, and accessibility for analysis. Data engineers play a crucial role in enabling data-driven organizations. The field of data analysis offers a rewarding and challenging career path for those passionate about data and its power to drive positive change.